All right, well, first, thanks for coming. I just got here yesterday. I will be here for the rest of the semester. I work on number, semantics, anything related to those things. So if you'd like to talk with me personally about any of that stuff, I'd be happy to meet with anybody or just to talk about whatever you want to talk about. But today we're going to be talking about the relationship between semantics and ontology, specifically the existence or non-existence of numbers. And if you're familiar with this area, some of this will be familiar to you, but what we're going to try to do is offer a quite novel kind of argument for the existence of numbers based on semantics. So even if some of it is kind of familiar, I'm guessing the basic approach probably will not be. All right. This is a title to a different paper that we wrote some time ago, but it's still, I think, appropriate for this talk. The two papers are related enough. Okay, so here's the epigraph for the paper. It seems to summarize what we think the main problem is pretty well. The main cause of philosophical disease, a one-sided diet. One nourishes one's thinking with only one kind of example, and that's from Wittgenstein. Main problem we're going to be arguing for the traditional dialectic concerning semantics and number is it suffers from a one-sided diet in this sense. Okay. So the talk is going to be broadly concerned with the meanings of number words, such as 2 or 3 or whatever, and ontology, as I mentioned. Specifically, just the truth of broadly number-related statements, statements broadly involving number, such as 2 is an even number. Does the truth of those sorts of statements support realism? That's the view that numbers exist. Or is it consistent with nominalism? That's the view that numbers, or really any kind of abstraction, does not exist. So we're going to argue for 3 claims. First, the traditional dialectic regarding the semantics of number words and the existence or non-existence of numbers is flawed in a pretty bad way, we think. Secondly, providing an empirically adequate semantics for number words provides a novel kind of argument for realism, one that, as far as I know, is not well known in the literature. And 3, that extant anti-realist responses, that is the standard sorts of responses to the familiar dialectic, they do not plausibly generalize to this new kind of argument. So the upshot is going to be that this new argument that we present is going to be a much stronger argument for realism than either realists or anti-realists have traditionally supposed. Okay, so that's just the overview. Here's the plan. I just gave you the introduction. We'll start with what we're going to call the simple argument for numbers. This is sort of the traditional dialectic regarding semantics and ontology. We'll go into number word polysemy. I'll explain what that is. Then based on that, we'll give a new argument for realism that we call the strengthened argument for realism. We'll look at some very general anti-realist responses to this new argument, argue that they don't work, and then we'll summarize conclusions and then end with a third view briefly. All right, so that's the plan. Here's the simple argument for realism. So again, this is a traditional, very familiar kind of dialectic within the philosophy of mathematics. It begins with Frege, and it's been reiterated many, many times throughout the history of 20th century philosophy of mathematics. So here it goes. Consider this sentence: 2 is an even number. Suppose that sentence is true. And we have the following argument. First premise, we call it truth conditions. That sentence is true if and only if there exists a referent of the word 2, which is both even and a number. Seems plausible enough. So those are the conditions under which this sentence would be true. Second premise, which we're calling realism and truth value, the sentence is true, 2 is in fact an even number. And therefore, right, combining 1 and 2, we get the conclusion, which we call realism in ontology, a number exists, right? Hence realism. Very simple argument. The sentence is true. For that sentence to be true, a number has to exist, hence a number exists. And as I said, this kind of argument, not exactly this form, but something like it, was originally given by Frege. More recently, and very famously, something like it was defended by Benassera. Bob Hale explicitly formulates this argument in his 1987 book. Hoisting-Lennebaugh also gives an argument that's very similar, and I get the same one in my monograph. Shameless plug there. If you're interested in the monograph, let me know. I'm happy to share it with you.
It's really good.
Okay.
I was the editor on it.
Yeah, he was the editor. Is it clear enough? Hope everyone following along. It's the simple argument for realism. Pretty simple. Now, why should you accept the argument? Well, there are only two premises, right? So why accept either one of the premises? Perhaps the most straightforward reason for accepting the first premise, remember that was that the original sentence was true if and only if there exists a number that's even. That follows from compositionality. So what is compositionality? Well, there are different definitions of what compositionality is, but my favorite one comes from Barbara Partee, which is kind of an elaboration of Montague's original definition of compositionality. So compositionality requires a mapping from lexical categories like noun, verb, etc., to a range of semantic types. Why do you need a range of semantic types rather than a single semantic type? That has to do with what's called polymorphism, which we'll talk a lot about here in a second. Okay, so given the syntactic similarity between our original sentence, 2 is an even number, and this sentence, Mars is a red planet. If 2 and Mars, A, belong to the same lexical category, and B, we have similar syntactic structures, which we do, then whatever the semantic function of Mars here should also be the semantic function of 2 in the original sentence. And the default assumption amongst linguists, I think, most semanticists, and also probably among most philosophers of language, is that the semantic function of Mars here is that of a singular term. That is, it's a referential type expression. Its purpose, its function, is to refer to an object, in this case, Mars. So by compositionality, we often infer that 2 in the original sentence is also a singular term. That is, its semantic function is to refer. Okay, so that's maybe the most straightforward argument you can give for first premise. The second premise, there are different reasons for thinking that 2 is an even number is true. At least 3 kinds of arguments have been given in the philosophy of mathematics. One is very familiar, it comes from Frege. Mathematical claims are true in virtue of being derivable from some presumably true logical principle or principles and suitable definitions. So this is known as logicism, philosophy of mathematics. That's a logicist justification for the second premise. Second one is known as the indispensability argument, very famously associated with Klein and Putnam. According to this justification, mathematical claims are true in virtue of being indispensable to our best science. You can't do science without acknowledging the truth of those sorts of claims. So the argument goes. A third kind of justification is that we don't need to justify mathematics on the basis of logic or our best science or whatever else philosophers might tell us. Mathematics sets its own legitimate justification, standards of justification. And by those standards of justification, clearly it's true that 2 is an even number. Ask any mathematician you know, I hope they'll tell you that's true, right? Okay, so those are 3 different reasons that have been given for accepting the truth of the statement. Okay, again, all this should be relatively familiar from the philosophy of mathematics, nothing super controversial so far. Yeah, we get 3 different views, familiar views from the philosophy of mathematics, depending on which premise in this argument you accept or which premises. So realism, again, that's just the view that numbers exist. Most realists would just accept the argument as sound. Both the premises are true, the argument is valid, hence the conclusion. We have to accept the conclusion. So numbers exist. There have been lots and lots of different versions of realism. For our purposes here, that doesn't really matter. Frege was a realist. Stewart is a realist, a structuralist. Hale and Wright, realist. Oystein, Linnebaugh, lots of different versions of realism. Lots of different views about what sorts of things numbers are. For our purposes here, that doesn't really matter. All that really matters is that numbers exist, whatever they may be like. Okay, so that's the first view. The second view is what we call non-referentialism. So that's the view that the truth conditions that we gave for the original sentence, those are incorrect. Why? Because they presuppose that two in the original sentence is a singular term. But that's wrong, according to this view. Actually, two in that sentence is the same kind of expression that we have in sentence 3. Mars has 2 moons. Well, 2 there is either an adjective or a determiner, depending on what you have different views about that. Whatever that turns out to be, that's the same category of expression 2 and 2 is an even number is. And generally, adjectives and determiners aren't in the business of referring, right? That's not their semantic function. Hence the label non-referentialism. The view is that 2 in the original sentence, 2 is an even number, is a non-referential expression, the same way that 2 here is. Okay. So non-referentialism rejects the first premise. Fictionalism rejects the second premise, namely the truth of the original sentence. That premise is false because it requires the existence of an abstract object, namely a number. So this presupposes that numbers, if they exist, are in fact abstract. You don't have to accept that, but it presupposes that. And since abstract that do not exist, according to fictionalists, the sentence simply cannot be true. Maybe it's false, maybe it suffers from some sort of presupposition failure. In either case, it can't be true. I should have mentioned that non-referentialism has been defended only by a couple philosophers, most notably Thomas Hoffweber. Friedrich Moltmann also defends it, at least in part. But by far the most extensive non-referentialist is Thomas Hoffweber. We've had many arguments with him in the past, and they'll probably continue. As far as fictionalists go, maybe Hartry Fields, most well-known fictionalist. Balaguer, Stephen Yablo has fluctuated in his views. At one point, he was a fictionalist. Harry Lang also. Okay, so these are all familiar positions within the philosophy of mathematics. They emerge based on how you react to this simple argument. Okay. Now, each of these views, of course, also faces serious challenges, hence why they are one of the major views within the philosophy of mathematics. If they didn't have any challenges, there'd be nothing to argue about here, I guess. So the major challenge for realism is one that will be familiar to you if you know anything about the philosophy of mathematics. Was famously, or made famous by Paul Ben-Asra. Oystein, Linnebaugh calls it the integration challenge. If numbers are abstract and yet reliable beliefs are prototypically formed via perception, then to quote Oystein, why is it just not a happy accident that our mathematical beliefs tend to be true? So you might think the reason I'm justified in believing that there's a table here is because I can see a table, I can feel a table, etc., but I can't feel or see or anything else a number, right? Seems like numbers are abstract. So why isn't it that any beliefs I have about numbers or any other kind of mathematical object is a happy accident that if they turn out to be true, unlike with the desk in front of me? Okay, so that's the major challenge for realism. The major challenge for non-referentialism, maybe there are a couple. The first is, why think that 2 in the original statement is not a genuine singular term, right? Looks just like Mars. Looks like a name. And seemingly names occurring in argument positions, that is, in positions where they are the arguments of predicates, look like they are referential type expressions. Their purpose is to refer. But why think that 2 in the original sentence should be any different from Mars in the other sentence? So that's one challenge. Non-referentialists give various purported semantic data to get us to think that numerals, that is, names of numbers, are not referential expressions. We won't go into that here, and I'll just speak for myself. I don't think any of that data is very convincing. The second challenge is to extend non-referentialism. Numerals aren't the only purported singular terms in English. So, for example, all of the underlying expressions in 4a, 4b have been claimed to be singular terms, even by some non-referentialists. So, for example, the number 2, Federico Moltmann says, yeah, that's a singular term. It refers to a number. So Moltmann is not, in fact, a nominalist. She's a realist. She just thinks that numerals themselves are not singular terms. These complex expressions, like the number 2, for her, those are singular. If that's an anaphoric pronoun, refers back to something, what is that thing? Presumably a number. Mary's favorite number, again, sorts of genitive constructions you might consider to be singular terms. Many have argued that. That number, this demonstrative phrase, is sort of a prototypical singular term. And these functional expressions like 1 plus 1 or the successor of 1. These are known as functional nouns, functional phrases. Those are also presumed to be singular terms. So what's my point? My point is, if you're going to be a non-referentialist and you also want to defend nominalism, not only do you need to be a non-referentialist about numerals, that is names of numbers, you're going to have to be a non-referentialist about all of these different sorts of expressions. Furthermore, English isn't the only language, obviously. So if you really want to defend nominalism and you want to be a non-referentialist, you've got to defend a very, very strong thesis. Namely, there are no singular terms representing numbers in any natural language whatsoever. And I don't know of anyone who's defended that claim. The closest that has, the philosopher who's come closest to defend something like this, at least for English, is Thomas Hofstadter. And as far as I know, he's the only philosopher who has defended something like that. So again, the major challenge for them is why think that that is the case. Sure looks like there are singular terms for numbers in at least some languages. The third, finally, the challenge for fictionalism, the major challenge is, if none of our mathematical talk is true, right, again, either false or suffers from presupposition failure, then why is it that mathematics seems so successful? Why are we able to use mathematical planes in engineering, building bridges, science, whatever, right? Why is mathematics applicable if none of it is in fact true? Okay, those are the major challenges. And the first point we want to make is that this whole dialectic I've just sketched for you is flawed in one very crucial respect. Notice we've only focused on one sort of example. 2 is an even number. Well, it turns out that number words like 2 have all sorts of different uses and corresponding meanings, not just one kind of use. The kind of use I focused on is just a numeral, right? A name of a number. But 2 obviously can also occur as an adjective. Mars's moons are 2 a number. 2 there is a predicative adjective. Those are Mars's 2 moons. 2 there is an attributive adjective. Mars has 2 moons. Again, depending on what your view is, that's either an adjective or a determiner. But it has a different semantic type from 2 in 5b. Mars's moons number 2 in total. 2 here is a complement of a verb, kind of like Mary's canoe weighs 4 pounds, right? Something like that. The number of Mars's moons is 2. This is what's known as a specificational sentence. It occupies a special position in the philosophy of mathematics and the philosophy of language, because Frege specifically talked about this sort of construction. But for our purposes here, it's just one of a number of many other uses of 2. We won't focus too much on that here. 2 is an even number. We've already gone over that. The number 2 is even. I just learned recently, thanks to another paper I read, that this is called a close appositive. Generally, any kind of construction of the form the noun, or say this noun compound, is going to be called a close appositive. And as far as I can tell, the general assumption seems to be that close appositives are singular terms, they're referential expressions. Michael Jordan is roughly 2 meters tall. Here, 2 meters tall is designated Jordan's height, so it's a measure of how tall Jordan is. Nadal was number 2 in the world in men's tennis. Here we have 2 designating the ordinal position of Nadal, right, where he ranks among men's tennis players. So we have all these different uses of 2, and any empirically adequate semantics for number words, given that fact, will need to meet 2 conditions. And in fact, in linguistic semantics, most semanticists who want to account for this do try to meet these 2 conditions. First, the first one we call empirical coverage. It needs to provide meanings for all the different uses of two, right? We want an account of the semantics of number words that gives meanings to all the different uses here of two, not just one of them. And secondly, and maybe more importantly, we want an account that explains why all the different meanings here are intuitively related. Okay, so some of these different uses of two have something to do with cardinality. It tells us how many moons Mars has, for example. Other uses have to do with measurement, that's an H here. Others have to do with ordinality, that's I here. And others have to do with arithmetic, right? That is F and G. Why is that? All of these are in some sense broadly number related. It sure be nice if our semantics for number words tell us why these different meanings are semantically related. And in fact, standard analyses within linguistic semantics attempt to do that. How do they do that, you ask? I'm glad you asked. That's what we're going to talk about next. So to say that the different meanings of two are related is just to say that number words are polysemous. Words are polysemous if they are A, ambiguous, so they have different meanings, but B, those different meanings are related, right? What a polysemous word is. And the reason that number words are polysemous, the standard reason that's given, is because they are what's called polymorphic. An expression is polymorphic if it can take on different semantic types and thus different semantic functions in different semantic environments. If you've taken a class in semantics, you know what a semantic type is. If you don't know what that is, that's okay. Semantic type is sort of the analog of a syntactic category. Just as any expression can be a noun, a verb, preposition, etc. Any expression can take on a type, a semantic type, that sort of corresponds to that category. And they can be characterized by whatever semantic type it belongs to. So to say that an expression is polymorphic just means that it can take on different semantic types and also different syntactic categories, potential lexical categories, based on a phenomenon that's known as type shifting. As the name suggests, that's just a way of shifting the semantic type of an expression. And since the semantic function of an expression is determined by its semantic type shifting also is a way of getting expressions to perform different semantic functions in different syntactic environments. Natural language is rife with polymorphism. It's not just number words, color words, names. I think maybe all categories of expressions are polymorphic, right? Natural language is super flexible with respect to the sorts of meanings it can take on. And what separates polymorphic with sort of ambiguity, polysemy that's associated with polymorphism is that the meanings that these expressions can take on are systematically related. Right? So there's you can predict what meanings a polymorphic expression can take on based on the type shifting principles that are available for it. You still with me? Does all this sort of make sense? No. Okay. So that's just background. There are going to be we can divide extant views into two kinds of polymorphic analyses that exist. The first we call polymorphic substantivalism. That's the view that the lexical meaning of a number word is that of a numeral, so a name of a number. And all other meanings that number words can take on are derivable from that numeral via type shift. Polymorphic adjectivalism, on the other hand, is that the lexical meaning of two is either that of an adjective or determiner, and all of the other meanings are derivable from it, again, via type shifting. So if we go back to the different uses here, according to substantivalism, 2 here and 5F is the basic one. That's the lexical meaning of two, and all the rest of the meanings are derivable from it. According to polymorphic adjectivalism, it's either going to be this one, that's the predicative adjective, or it's going to be this one. That's the attributive adjective or determiner. Again, there are different analyses on which all of those are different. The meaning of two differs, right? That's what separates different polymorphic analyses. For our purposes here, it doesn't really matter. Specifically, it doesn't matter which version, which kind of polymorphic analysis is correct. We have our own views about which kind is best, but that doesn't really matter for our purposes here, because on both kinds of analyses, numerals are going to be singular terms referring to numbers. So that first premise in the simple argument is going to turn out to be correct on all polymorphic analyses. Secondly, all meanings of number words share a certain element in common, namely they implicitly reference a number. That's what ties the various meanings of two together. They all, as we'll see here in a second, implicitly reference the number two. And it's going to follow from that none of those 9 uses of the word two I showed you would be true if numbers don't exist. That's going to be the basis for the new argument for realism. Okay, so here are the formal details. I won't go in too much detail. That's why I put them all on one slide. I'll just talk quickly through this, and if it still looks like a bunch of formal Greek, that's fine. That's all it is for the moment. This just says that the lexical meaning of two is the number two. That's to say that the lexical meaning of two is a name. So this is what we call polymorphic substantivalism. On this view, you combine two with a type shifting principle that Fred Lampman calls num, or maybe I called it that. I can't remember at this point. It's been too long. Fred has it anyway, and maybe I gave it a name. It combines with the number two and returns a predicate that is true of, let's call them collections that have two parts. So this says, this is a cardinality property of being two in number. So that's true of any two pencils or any two desks or whatever. Okay, so that's polymorphic substantivalism. Basically, we start here in the diagram. We apply num, we get to here, and then through the basis of all these other type shifting principles, we can get anywhere else in the map, anywhere in the diagram. According to polymorphic adjectivalism, this is Susan Rothstein's version. There are different versions, but the one I want to use is Susan's. The lexical meaning of two is just this same cardinality property that we derived here through the substantivalist analysis. But in this case, we use a different type shifting principle that Barbara Partee calls nom, for nominalization. To nominalize an adjective or any other expression is to turn it into a name, hence nominalization. So this takes a cardinality property like this and returns a name, namely a name of the corresponding property, being two in number. In philosophical parlance, we call that a reified property, right? Thinking of a property as an object itself. Bernard Kirpia calls it instead a individual property correlate. I think I got that right. But what he means is reified property. Okay, so on this view, we start here, and we can get to anywhere else in the diagram thanks to this schema that Susan has. The schema says for any number n, that number is identical to the property of being in a number. So in other words, every number just is a reified cardinality property. So thanks to this schema, we start out with the adjective, we nominalize to get this property, the name of the property. That's identified with a number, which can then get us to all these other meanings via the other type shifting principles. So basically on both sorts of views, they're both able to cover all of these different meanings, and they do so through the use of basically the same set of type shifting principles, with the exception of num. So the one that's characteristic of substantivalism, that's num. The one that's characteristic of adjectivalism, that's this schema, RSE. Otherwise, the two views are practically identical. It's just a matter of which meaning they think is lexical. This make sense? Yeah, go ahead.
Why do you think the availability of polysemous adjectivalism, why do you think that's not a good argument for non-referentialist again?
Well, even on the polymorphic adjectivalist view, we start here, we nominalize. That just is the referent of a numeral.
Okay.
So even if you're a non-referential, even if you're an adjectivalist, you still think that numerals refer to numbers.
Okay.
It also expressions like the number two, they refer to numbers. What are numbers? Well, thanks to this schema, they are reified cardinality properties.
The way I like to put it is that even if it starts off as something other than as a singular term,
right? When
it shifts into singular term position, then you need a referent.
Yeah, exactly. And this just tells you what that referent
is. What the referent is.
Yeah. So think of this as like a meta semantic scheme. You want to ask what is a number, right? That's a meta semantic question. That's what this is telling you. It's a reified cardinality property. Make sense?
On that version.
on that particular version of adjectivalism.
Yeah.
There are other versions, but this is the one that I think is best for illustrating the dialectic. Okay. So that's just the semantics. What lessons should we draw for philosophy, specifically philosophy of mathematics? So there are three general lessons that we ought to learn here on the basis of this stuff. So one of them has to do with another very familiar dialectic within the philosophy of mathematics. Frege very famously notices that number words have at least two different uses: numerals, and what I was saying earlier was a specificational sentence. The number of Mars's moons is 2, right? Versus Mars has 2 moons. Those are the two sorts of uses that Frege explicitly noted. So speaking on that, Michael Gummett writes, number words occur in 2 forms: as adjectives, as in ascriptions of number. Again, Mars has 2 moons. And as nouns in most number theoretic propositions. Again, the number of Mars's moons is 2. Finally, any analysis must display the connection between these two uses. So what's the relationship between these different uses? Evidently, there are 2 strategies. We may first explain the adjectival use of number words and then explain the corresponding numerical terms by reference to it. This we may call the adjectival strategy, or conversely, we may explain the use of numerals as singular terms and then explain the corresponding number of adjectives by reference to it. This way we may call the substantival strategy. So 2 strategies of analysis: the adjectival strategy and the substantival strategy. In effect, if you're a substantivalist, you want to explain away non-referential uses of number words in some way. If you're an adjectivalist, you defend the adjectival strategy, you do the opposite. Sure, it looks like number words are used referentially, but they're really not. These are uses, these are determiners or adjectives. Now, both of these strategies have been defended in the literature. Frege suggested the substantival strategy, but he wasn't really interested in natural language as such. He was trying to concoct a scientifically ideal language, a logically perfect language. But Crispin Wright really does defend this strategy, or at least he rhetorically suggests it. If you want to know more about it, see my monograph.
Since Marcus isn't here, we can make all the claims we want about Frege.
Yeah, that's right. That's right. He'll only retrospectively.
Well, he'll be listening to the
Yeah.
recording, and then he'll go on.
That's right. And so you can complain later, Marcus. The adjectival strategy has been defended by at least a few different philosophers, at least with respect to some cases. Again, probably the most extensive defender of the adjectival strategy is Thomas Hofstadter. Here's the important thing. The presumption is that number words exclusively function either referentially or non-referentially, hence the existence of 2, count them, strategies, right? But clearly, if any one of these polymorphic analyses I just mentioned is correct, that's a false dichotomy. There is in fact a third possibility, which is number words can function both referentially and non-referentially, right? So again, this whole dialectic is flawed given standard polymorphic analyses within linguistics. So that's one lesson that we can draw. Here's the second one. So contra-referentialism, remember non-referentialists say that 2 in the first example is not a singular term, it's an adjective or a determiner. Well, again, obviously, for exactly the reason that you asked, even if you are an polymorphic adjectivalist, you still recognize that number words can function referentially, right? This is a singular term, even if you think that the lexical meaning of 2 is not that of a numeral. You still think that this is a singular term referring to a number. Now, why would you think that? So I just told you what is the case according to all analyses within linguistic semantics, but why think that? Again, non-referentialists at least give us some evidence, they think, that numerals are non-referential, at least. Well, again, one very simple argument just appeals to compositionality, right? So again, by compositionality, if 2 here is a name, and names are generally singular terms, then it has to be a singular term, at least when they occur in this sort of position. And in fact, it is a name. Right? So what reason can we give for this? Pointing at 4, 5, and 6, how many of these numbers are even? 2 is. That's bad. 2 are great. Again, 2 here has to be a numeral. not an adjective or a quantifier. 2 is an even number. It is also prime. Good. Singular anapra, right? They are also prime. Bad. Plural anapra. Again, that needs to be a name. Pointing at 1, 2, or 3. Sorry, 1, 2, and 3. Mary asks, which of these numbers are even? John answers, exactly 2 is even. That's not English, right? That's bad. But 2 is even is fine. So again, this can't be modified by adjectives like exactly. On the other hand, adjectival uses of number words can, right? How many numbers are here? Exactly 3. That's fine. So again, this has to be a numeral. It's a numeral, a name of a number by compositionality. It has to be a singular term. That's a simple argument. Here's a second kind of argument that may be a bit more controversial. Numerals license what some philosophers have said to be characteristic of singular terms. So 2 is an even number, therefore there's an even number, namely 2. That seems like a good inference. 2 is an even number. It does not follow from that more than one number is even. Right? You can't infer that. Here's an even worse one. 2 is an even prime. This is due to Susan Rothstein. 2 is an even prime. It does not follow that 2 numbers are both even and prime. That's a better one. Yeah. Again, 2 has to be a singular term. Okay, so those are two pretty straightforward arguments that numerals are in fact singular terms, and they refer to numbers, just as extant polymorphic analyses suggest. Contra non-referentials. A third, and maybe the most important lesson for philosophy of mathematics, is that all of these different meanings that 2 can take on are all related. And as you can see here, regardless of whether you understand what any of this other stuff means, you can see that the number 2 occurs in all of those different denotations. In a sense, very loosely speaking, the number 2 is sort of the formal witness to the polysemy of 2, right? It's what ties all these different meanings together. Even when 2 is being used non-referentially, as in this case, when it's being used as a predicative or attributed adjective. Why? Because of this thing. This is called a measure function. A measure function is just a function from entities to numbers along some dimension of measurement. Intuitively, it represents the measure of something, how tall something is, how fast something is, or in this case, how many of some things there are. So again, because non-referential uses involve measure functions, and measure functions by definition are functions from entities to numbers, they presuppose the existence of numbers. Even non-referential uses of number words presuppose an ontology of numbers. Now, why would you think that? Why would you think that these non-referential uses involve measure functions? Well, one, again, very straightforward argument is that the syntax of numerical modification is very similar to the syntax of measure phrases. Those are phrases which explicitly invoke measurement. So how tall is Michael Jordan? Call it a degree question because it involves a degree of height. How many moons does Mars have? Again, that's a degree question. It's asking about the cardinality in this case. Jupiter has larger moons than Mars. This is a comparative adjective. More is the comparative version for cardinality adjective. So Jupiter has more moons than Mars. Mary's canoes are 2 meters in length. This is a measure phrase. Mary's canoes are 2 in number. This is also a measure phrase. So if you think that measure phrases in general need to invoke measure functions, as far as I know, every semanticist thinks that. There are different views about what measure functions do, but regardless, I think everyone thinks that. And you're also going to think that non-referential uses of numerical adjectives also involve measure functions, and thus functions from entities to numbers. This makes sense? Kind of? Yeah. Okay. What's the highlight? All uses of number words, regardless of whether they're referential or non-referential, presuppose the existence of numbers. That's the takeaway point. So this leads to what we're going to call the strengthened argument for realism. So to summarize what I just said, on all extant polymorphic analyses, all meanings of 2 implicitly reference a number, right? Either through measure functions or through explicitly referencing a number, as in numerals or the number 2. So consequently, none of those 9 examples I gave you would be true if numbers don't exist. Right? Again, just look at the denotations for these different uses. If numbers don't exist, then none of those corresponding uses could be true. Everyone see that? Okay.
Questions at the end or?
If you want, I think now or later.
Well, if I may ask a question right now, so in introductory courses, when we teach students about first order logic,
Yeah.
The sentence "there are 2 students" is represented with a
Okay.
first order characterization that doesn't involve numbers.
Yeah, yeah.
And many of these can be. I'm not, of course, it doesn't work for all users, but one might ask, why not that? I know that not all numbers are first order definable, but still, 2 is, right? It's 2, you can do that.
Yeah, let's go back to that's a great question, Stephanie.
So I mean, I'm not actually, I'm sort of devil's advocate here. Right?
Yeah, no. That's totally a fair question, right? So Mars has 2 modes. You've taken a logic class, you know exactly how you should render that. There are different ways depending on whether you understand that it's exactly 2 or at least 2. But fair enough. We all know how to do that in terms of first order logical quantifiers, identity, non-identity. Well, that translation of 5C implies nothing about the existence of numbers, right? So if that's the correct translation, clearly the truth of that sentence does not commit us to the existence of numbers. And I'm so glad you pointed that out, because that's precisely the sort of strategy or the kind of observation that fictionalists are going to be relying on. And we'll get to them in just a second. I don't know if I'm going to steal the thunder if I answer the question right now.
So
Maybe, well, let me get to that and then it'll unfold whether it would have stolen the thunder, but then I'll reveal at that point what the answer is. Does that work?
Yes.
Okay, all right. All right, I can't think that far ahead, sorry. All right. Where am I? Right. Okay, so here's the strengthened argument. Let's, for the moment, sustain doubt and just accept that the polymorphic analyses are correct. That would lead us to this new argument that we're going to call the strengthened argument for realism. This time it has 3 premises rather than 2. The first premise is what we're calling implication. If numbers don't exist, but some polymorphic analysis is correct, then none of the number-related things we say are true. That is to say, none of those examples I gave you would be true if numbers don't exist, and at least one kind of polymorphic analysis is correct. You should see that just follows from the semantics I just highlighted. Second premise, strengthen realism and truth values. Some of the number-related things we say are true. In other words, at least one of those sentences I gave you is true. It doesn't have to be all of them, but at least one is. Third premise, at least one kind of polymorphic analysis is correct. Again, it doesn't matter which one it is. And it doesn't even matter which specific version of which kind it is. If any polymorphic analysis is in fact correct, then, at least one specific version of a polymorphic analysis is correct. If all that is true, those 3 premises are true, then numbers exist. Now, why does it say strengthened version? Strengthened argument for realism. Well, remember the first one, the simple argument for realism, depended importantly on numerals like 2 functioning as singular terms in very specific syntactic environments, namely mathematical environments. All of those examples I gave you, out of all those examples, only 2 involved referential expressions in mathematical environments. All the rest had something else to do with cardinality or measurement or ordinality, something else. So this argument depends in no way on numerals being singular terms referring to numbers. So that's one way of strengthening of the original argument. The second way to strengthening is, this is a premise, the second premise. Some of the number-related things we say. That's a premise that everybody accepts. Realists, non-referentialists, and fictionalists alike, for reasons I'll give you here in just a second. Okay? So that's why this is why we're calling it the strengthened argument for realism. It strengthens the original simple argument in these 2 ways. Now let me motivate the 3 premises. That's where we're going to get your question on the next slide. Why should you accept the first premise? That was implication. Well, because it falls immediately from the semantics I just presented, right? If at least one such polymorphic analysis is correct, then none of the number-related things we say are true if numbers don't exist. And again, by number-related things, I just mean any of those 9 sentences. There are others that we could talk about, but surely that's enough. 9 sentences is enough. Why should you accept the second premise? That was strength and realism of truth value. So again, the claim is that at least one of those sentences is true. And again, this is something that obviously that's something that realists accept. They accept the truth of 2 as an even number, for example. But this is something that even fictionalists and non-referentialists accept. Moreover, it's something that they have to accept because it's important to their own views that they accept at least one of those sentences as being true, but for different reasons. If you're a non-referentialist, you're going to say that 2 here in 11a has the same non-referential semantic function as 2 here in 11b. And you're also going to say that both sentences are true. They're true in virtue of this being a non-referential expression, right? So again, non-referentialists are happy to accept this premise. They can say that all of those sentences I gave are true. They're all true in virtue of 2 functioning as an adjective or a determinant, for example. Fictionalists, on the other hand, are going to say that this sentence is true for an importantly different reason, specifically the one that Stefan was pointing to. This is a sentence which can be rendered in first order logic with identity without commitment to numbers. And that is supposed to explain why mathematical statements, at least statements of simple arithmetic, are useful. I'll get to that on the next slide. But I just want to flag right now, it's really important to fictionalists that this sentence be true. If it's not true, then at least one very prominent explanation for the original challenge to fictionalism that we gave. Again, why is mathematics useful if it's not true? The answer is going to be in part because this sentence or sentences like these are true. Okay. And then finally, for the third premise, polymorphism, why should you think that at least one polymorphic analysis is correct? Quite simply, it's because that's our best extant explanation for why number words are polysemous. Why are the various meanings that number words can take on related? Because one of these analyses gives the correct account, right? Again, it doesn't matter which one it is to us, but those are our best accounts as it stands right now of why number words can take on different meanings that are related. Now, maybe it turns out that some other polymorphic analysis turns out to be correct, but as long as one kind of polymorphic analysis is correct, that's going to justify this premise. So we're relying here on what's called an inference to the best explanation, right? Our best theory says X, therefore, all else being equal, we ought to accept X. Very familiar kind of inference. All right. I dedicated a whole slide to just explaining this fictionalist point because it may not be obvious. So let's get into it. Why are some arithmetic statements useful despite being untrue, according to some fictionalists? Well, Hartree-Field gives, I think, at least for what was for a long time sort of the standard line. And he's got a new version of the original Science Without Numbers in which he says this. The view allowed us to regard sentences of the form, they're exactly 87F. So that, again, that's exactly the sort of sentence that you can render in first order logic. As literally true, so the sentence is true, since they could be paraphrased in terms of first order logic with identity, quantifying over nothing but F's, and in particular, and importantly, not quantifying over numbers. Why did it allow you to do that? Well, because for Field, there's nothing wrong with first order quantificational logic, especially if it's consistent with nominalism, right? And that's what he's claiming here. And the reason that translatability into first order logic is important, the reason why that would explain why arithmetic statements are useful, has to do with explaining the validity of certain arguments. So in particular, there's a kind of argument that was due to originally to Hillary Putnam, which we're going to call the aardvark argument. It's one that Field recites in Science Without Numbers. So here's the argument. There are exactly 21 aardvarks. On each aardvark, there are exactly 3 bugs. Each bug is on exactly 1 aardvark. So there are exactly 63 bugs. This is a valid argument in first order logic, right? It would be valid regardless of whether we had any numerals or singular terms for numbers. Again, if you know a little logic, you'll know how to render that. You can also tell that determining that this argument is valid would take forever. Right? Just translating this first premise alone would take more than a paper, a page of paper.
That's still not forever.
Okay, fair enough. An inordinate amount of time given my patience. Let's say that.
That's fair.
Yeah. All right. Field rightly says, well, one way to get around this, one way of seeing that the argument is valid without having to write out all these quantifiers and identities and whatnot, is to introduce singular terms or numbers. We have this little hash operator. That's a singular term forming operator. It's the number of operator. Well, once we introduce that, it becomes really easy to see that this is in fact a valid argument. But, and here's the crucial point, by introducing these singular terms, it's not like we're making the argument valid. It was already valid all along. It just is expedient to introduce these singular terms. So his idea is, by speaking as if numbers are objects, that is, by introducing singular terms for numbers, all we're really doing is making inferences like this easier to see as valid than they otherwise would be. So if we spoke a purely quantificational language, and we could apparently, we would know that this is, or we can at least in principle tell that this is a valid argument. It's difficult, hence we introduce singular terms, makes our lives a lot easier. But that does not go against the fact that we could speak this way, and we would speak this way successfully without talking about numbers as objects. Now, notice that the presumption here is something like the following. Because we can translate certain sentences into first order logic without commitment to numbers, we should be translating in that way, right? That's the crucial presumption here. So to go back to your question, Stefan. Why shouldn't we be translating numerical statements like there are, Mars has 2 moons into first order quantificational logic? Well, I gave you an argument, right? Where was it? Here we go. There are these syntactic similarities between numerical adjectives like 2 moons and measure phrases. Measure phrases, everyone agrees, involve measure functions. The syntactic similarity between those two might also lead you to believe that numerical modifiers also involve measure functions. Here's a second kind of argument that I hadn't mentioned here. In classifier languages like Chinese, like Mandarin Chinese or Korean, for example, the syntax is explicit. When you have numerical modifiers, you need something like to classifier noun. What that means is, so if I want to count 2 cups on the desk, because all nouns are mass in classifier languages, I need to say something like 2 objects of cup on the desk. Once you have a classifier like 2 objects of cup, that's clearly a measure-like phrase. Right? The syntactic form of a classifier phrase in a classifier language is exactly parallel to a measure phrase in a classifier language. Now, we don't speak a classifier language, so that's sort of hidden, right? But it has been argued, at least, that English at one point, old English, was a classifier language. So, I mean, that may give you some reason to think that, in fact, numerical modification involves measure functions, right? Because it does so. It explicitly does so in classifier languages. Is that helpful?
Yeah.
Okay. Cool. All right. So I've given you the new argument, right? The strengthened argument. Obviously, I've convinced everyone here, but what if you're an anti-realist? What if you're a non-referentialist or a fictionalist? What are you going to do in response to this new argument? Well, we'll give you 2 options. Obviously, we could look over all possible options, but that would take forever. So we're just going to look at 2 very general sorts of options and see what's wrong with them. First response is what we're going to call generalized non-referentialism. So these are just generalized versions of the original responses to the simple argument. So according to generalized non-referentialism, all occurrences of 2, so all of the examples I gave you earlier, all of those are the same adjective or determiner. that occurs in Mars has 2 moons. So we just generalize that view to all occurrences. Similarly, according to generalized fictionalism, polymorphic analyses are absolutely right. So we just assume that they are correct. The problem is, all of those different uses of 2 require the existence of a number. And again, numbers are abstract, according to fictionalists. So if you're a generalized fictionalist, what do you say? None of our number-related talk is in fact true. It either is all outright false or it all suffers from presupposition failure. So these are just generalizations of the original views, the original anti-realist views. We're going to argue that they are deeply problematic. So you should reject both of these generalized views. So the main problem with generalized non-referentialism is that there's very, very little empirical plausibility to the idea that all uses of 2, every occurrence of the word 2, is witness to the same non-referential adjective or determinant. So there are actually 2 problems here. First, demonstrably, I can demonstrate to you that not all occurrences of number words are adjectives or determinants. So here's an example from Susan Rothstein. 2 2s or 4. This is like British English for learning how to add. Right? Put 2 2s together, you get 4. 2 here clearly has to be a predicate. Right? It's a predicative adjective. So sorry, this has to be a numeral. We're counting 2 things. Right? It's like saying two Elmos and a Bert are 3 dolls. Right? Elmo there is clearly a name. 2 here has to clearly be a numeral. Now, it's functioning as a predicate. That's why we can pluralize it. But nevertheless, it's a noun. Mary counted to 13. Good. Mary counted to 13 things. Really bad. Contrast that with Mary counted 13 things. Good. Mary counted 13. Weird. Right? You need something to fill the blank. In the first case, 13 is a numeral, it's a name. In the second case, it's an adjective or a term. Finally, I think I've already given this example. So pointing at 2, 4, and 6, which of these 3 numbers is Mary's favorite? 4 is, that's fine. 4 are bad, there are only 3 numbers there. So again, 4 there has to be a numeral, has to be a name. Okay, so that's why not all number words demonstrably are adjectives. Not all occurrences of number words are adjectives or determinants. The second problem is that not all occurrences of number words serve the same non-referential semantic function. I've already showed you why that has to be the case, right? We have all these different uses of number words. On everybody's account in linguistic semantics, those different occurrences correspond to different semantic functions that number words take on, or at least many of them do. So that's already problematic for this view, right? Generalized non-referentialism. But forgetting about the argument I gave you a second ago about what I called quantificational uses, let's just look at these measurement type uses. So 2 meters of growth. Maybe you think that even those could be rendered in first order quantificational logic. After all, 2 there is seemingly functioning as a modifier in the same way it is with 2 moons of Mars, right? But there are good reasons for thinking that even in this case, even in these measurement cases, 2 is not functioning as a modifier which enumerates the cardinality of a collection the same way it does with, say, 2 moons of Mars. So here's the context. So on the table, I've got 2 large oranges, 2 boxes filled with rope, and then finally a big rope that's 2 meters long. Got it? So here's the contrast. Hand me each orange, fine. Hand me each box of orange, good. Hand me each meter of rope, kind of weird, right? Kind of strange. Grab those oranges, fine. Grab those boxes of rope, fine. Grab those meters of rope, weird, really strange. I need large oranges, good. I need large boxes of rope, good. I need large meters of rope, kind of weird. I'm not the first person to point this out. All of these expressions are what are known as distributive expressions. So each is a distributive quantifier. Those is a distributive pronoun. And large is a distributive adjective. The reason that's important is distributive expressions distribute over individuated entities. The sorts of things that we can point out and say, that thing. Right? With mass nouns, we can't normally do that unless we coerce the mass noun. So the fact that meters of rope is not acceptable with distributive expressions suggests that meters of rope are not the sort of things that we can count. Why? Because counting presupposes individuation. You need individuated things to count. Meters of rope are not that sort of thing. That's why in measure phrases, 2, as in 2 meters of rope, is not an adjective. It's actually a numeral. It's referring to a number which is feeding into a measure function. It's saying, I'm the measure of whatever you're doing here. Weight, cardinality, whatever it is. What's my point? My point is not all, sorry, that was a long-winded way of saying not all occurrences of 2 can function in the way that non-referentialists say that they function. Even if we ignore numerals and purported referential occurrences of number words. All right, what's the problem with generalized fictionalism? So there are going to be 2 really significant problems. The first I've already pointed out. If we accept that none of our number talk is true, then the explanation that I gave just a second ago for why mathematics is useful is completely thrown out. Remember, the explanation was mathematical statements like 3 + 2 = 5 are useful because they can be rendered in first order quantificational logic as logical truths, right? In the same way that 5c can be rendered in first order logic as a truth. Now, you're rejecting that, right? You're no longer saying that this is true. Presumably, I don't know what they would say about the 4 + 3 = 7 case, but you can see that the general sort of explanation that was given for why mathematical statements would be useful no longer holds anymore. So you're rejecting that explanation. That's problematic because, again, the main challenge for fictionalism was, why is mathematics useful? Well, if you can't even get the basic case right, I mean, the very basic case, very basic arithmetic, what reason should we think that you're going to give a good response for the even harder, more complex cases, right? That seems like a pretty bad problem. The second one is far more intuitive. It's just really, really hard to take seriously that sentences like Mars has 2 moons, or Michael Jordan is roughly 2 meters tall, or Nadal was ranked number 2 in men's tennis, that those are actually not true. These are just mundane facts that, right? If you really don't know or you're unsure about those facts, just Google it, right? We all know that this is true. David Lewis famously responded to fictionalism by saying the following: to reject mathematics for philosophical reasons would be absurd. I'm moved to laughter at the thought of how presumptuous it would be to reject mathematics for philosophical reasons. Now, what he had in mind was fictionalism with respect to mathematical talk, like 2 + 3 = 5. What he's saying there is it's crazy to reject the truth of those statements for philosophical reasons. Now, obviously, if you're a fictionalist, you're not going to be moved by that consideration. You're going to say, yeah, well, look, my trust in anomalous epistemology is far greater than my trust in mathematical statements. So you're not going to be moved by what David Lewis says here. But there is sort of an analogous move to be made in light of what we've been saying, right? It really would be presumptuous, to quote Lewis again, if not outright absurd, to say that these sorts of statements, these very mundane statements, are not true on the basis of a prior commitment to nominalism, right? We have gotten this response for what it's worth. We gave this a version of this paper at Harvard-Field's, what was it? Harvard Fest. So it was just a conference so we gave something like this paper, and Mary Lang, a prominent fictionalist, took up exactly this sort of position. She said, yeah, well, I'm happy to just say that all of these sentences that you're talking about are not true. I just find that very difficult to, I mean, that's a bullet you can bite.
Yeah, that stopped us.
Yeah, I didn't know how to respond to that. It was just like, okay, well, I mean, well, it's philosophy. You're free to take whatever position you want. But if that's where you end up, saying that, no, actually, sorry, guys, I don't accept that Mars has 2 moons. Why? Because I'm anomalous. That's a tough position to be in, at least I think so. I mean, she did believe it was true before we gave the talk, right? Now she's saying she doesn't accept it.
I'm convinced.
I guess we did, yeah. Anyway, okay.
I think sometimes convince people of things.
I very seriously doubt that she really did. Yeah, maybe she was just playing devil's advocate. I don't know. Conclusion, we're almost done. So the traditional dialectic regarding the semantics of number of words and ontology, as exemplified by this simple argument, is a red herring. So what I mean by that, the case for realism should not depend importantly on the referentiality of numerals in very specific syntactic environments, namely arithmetic statements. Why? So we need to take the full range of number word uses into account, right? If we're going to draw any ontologically sophisticated conclusions. So taking the full range of number word uses into account and providing empirically adequate semantics for those uses suggests a novel argument, which we call the strengthened argument, for which extant anti-realist responses don't plausibly extend. That was the whole last bit there. Thus, the case for realism based on the truth of our ordinary number-related talk is far stronger than both realists and anti-realists have traditionally understood, right? So everybody has sort of got it wrong, at least with respect to the traditional dialectic. All right, we're going to end with one last view, which Balaguer calls paraphrase nominalism. This is a different version of nominalism than we've mentioned before. It's not quite non-referentialism. It's not quite fictionalism. So as we understand the view, it's a range of nominalist-friendly views which propose analyses of basic arithmetic statements that are substantially different from what their surface syntax suggests. So they're kind of like non-referentialism in that respect, but which are not obviously intended to be empirical proposals regarding the actual meanings of such statements. So for example, you might think that the original statement 2 is an even number should be rendered formally as something like necessarily if numbers exist, then 2 is an even number. Several philosophers have defended a view like this. Sometimes it's called if-thenism. Hilary Putnam defended the view at one point. Stephen Yablo has recently defended the view. There are a number of, Jeffrey Hellman might be considered to be someone who defends this sort of view. There are lots of paraphrase nominalists. If you know a little bit about ontology, this is a very common practice in philosophy. You translate whatever sentence you think is committing you to weird stuff, and you paraphrase it in a way in first order logic that does not commit you to the weird stuff. And then when someone says, are you suggesting that that's what the real meaning of this sentence is? You throw up your hand and say, I refuse to play that game, or whatever the response may be. All of those, any version of that sort of strategy is what we're going to call paraphrase nominalism. Now, famously, Burgess and Rosen pose a dilemma for paraphrase nominalism. The dilemma goes like this. Suppose your analysis of the original sentence is this one. Well, there are two options. Option one, that analysis is supposed to be a semantic analysis. It's telling us what the real meaning of the original sentence was, right? Or what the underlying logical form, or whatever your preferred locution turns out to be. If that's the case, then you should submit your analysis to a linguistics journal and let the linguist decide whether your view is any good. The second option is, this isn't meant to be a semantic proposal about the original sentence. It's something like a normative proposal about how mathematicians should be talking.
That's what they call the revolutionary one.
That's the revolutionary one. And again, the assumption is, well, they're not going to do that either. No nominalist is actually going to send their analysis to a mathematics journal as a proposal about how mathematics ought to revolutionize. So in either case, it's not really clear what the proposed intellectual contribution of this is supposed to be. And I think rightly so, some fictionalists have responded by saying, look, this is a false dichotomy. There's at least a third option. Third option being something like, well, this is meant to be something like a rational reconstruction of the original sentence, or conceptual engineering of some kind. There are various, right, or Kleinian explication. There are various ways you might understand what this is supposed to be. Our point here is, fine. So maybe there's a good reason for rejecting the original Burgess and Rosen dilemma. But there is another dilemma that's very similar to it, based on the strengthened argument that we just gave. Here's how it goes. So there's the hermeneutic horn. That was the original submit your version to the semantics journal horn. So 14, or whatever your preferred analysis is going to be. Either that is a semantic proposal providing the real meaning or the actual truth conditions or whatever of the original sentence. In which case you are encouraged to submit your account to a semantics journal. Why? Because these two sentences, the first one and this one, are not close to being truth conditionally equivalent on any polymorphic analysis. So what you're saying is that all extant polymorphic analyses are incorrect. Good. You're encouraged to develop your own polymorphic analyses, which does at least as good as all extant polymorphic analyses. Let's see it. This is the put up or shut up sort of response. Presumably, they're not going to do that. So what's the second horn? Well, that's the non-hermeneutic horn. So this isn't a semantic proposal. What it is something else. Again, Aquinian explication, whatever it turns out to be. Rational reconstruction, whatever the proposal is. Fine. In that case, the view collapses into a form of fictionalism. Why? Because paraphrase nominalism, whatever the express purpose of this is supposed to be consistent with nominalism. That's the whole point. And if it is consistent with nominalism, then whatever the purpose of this analysis is, clearly that's inconsistent with our best polymorphic analysis. So you are committed, once again, to all of our number-related talk being at least untrue. So now you have two jobs. Not only do you have to explain to us what this is supposed to be doing, what's the purpose of this analysis, you also, like the fictionalists, have to explain why is it that all of our mathematical talk, or number-related talk, I should say, is useful despite being untrue. I think that's it. Great. Thanks for listening.